Thank you so much for inviting me here. It's a great honour to receive an honorary, a great honour to have the opportunity to tell you a bit about my research. I've taken the liberty to change my title slightly. 28 years and counting, and I'm going to focus today on the research side of the work that we do rather than the conservation side. So I guess many people have not heard of a Saiga antelope. As you can see, it is the most beautiful species in the world. And it's also a very interesting species. It's a nomadic species that migrates seasonally over huge distances, up to 1,000 kilometers, between the desert zones, where it goes in the winter, and the steppe zones where it goes in the summer. It's a species that's found across Central Asia. I've got some picture here. So right in the far west, in Russia, is the pre-Caspian population. There are 3 populations inside Kazakhstan, of which one, the Ustjurt one, is transboundary. The Betpak Dala one, this one with the large area, is the one I'll mostly be speaking about. And then there's a population in Mongolia, which is a different subspecies and much smaller, so only a few thousand individuals. So although it's a very widely distributed species, it's one that is quite fragile in as much as it only has a few discrete populations. So I started on working on Saigas for a very random reason, which is that my father was a professor of Russian art history and literature, and I fancied going to the Soviet Union. So I found a way to do that. And at the time, the Saiga was a very obscure species. There was virtually nothing written in English about it, virtually everything written in Russian. Very well managed, much like the species you have here in Sweden. Lots of data available, but nobody had really done any analysis. So I thought, this is a great opportunity for me. And I was interested in traditional Chinese medicine because I'd been working on rhino horn before that. So I did my PhD, and part of it was on this species, and I just fell in love with the species and the place, and here I am, nearly 30 years later, still interested. So while I was doing my PhD, I started in 1988 and did my PhD through to 1990. But soon after that, as I was starting on my research career, geopolitics happened and completely changed my study system. So I like this slide because it tells you about the twin evils of communism and capitalism. So the first thing is communism and the second one is capitalism, and neither of them are very good for livelihoods or for wildlife. So this is a graph of livestock numbers on the steppes of Kazakhstan, and in 1933 is when collectivization happened, and the government said that all livestock should now be collective, and because they stopped the migrations, all the livestock died in the winter because the migration was to stop the animals, was to allow the animals to go to pasture. When they were no longer able to go to pasture, they died, and also local people slaughtered them because they needed to eat. So that was what happened then. And then again in the late 1990s, they decided to decollectivize. And unfortunately, what happened was that all subsidies were removed from the collective farms. And as that happened, again, in the harsh winters, people had to eat, people had to have incomes. And so there was very large-scale loss of livestock then as well. And that also came into the wildlife management sphere. So what was a well-managed kind of sustainable hunting regime for this species, the Saiga, was affected by 3 interlinked things. The first thing was that the species is used for traditional Chinese medicine. The males have horns. The horns are ground up and they're boiled in tea, and they're taken for fever and those kinds of diseases. For the first time in 70 years, the border between the Soviet Union and China opened, and it was possible to export the horns again to China, where there was a ready market. The second thing that happened, as I said, was with the decollectivization, because there was no work anymore in the rural areas, the villages collapsed. The only people who stayed were people who could not find jobs in urban areas and people who were interested in poaching. So this village here is the photo taken by my PhD student about 3 or 4 years after I had been there, when it was a thriving small town, and this is what she found. And the final thing that happened was that all the money for management and for anti-poaching was removed from the government agencies. So if you can imagine social and economic loss, opening the border with China for a highly valued product, and lack of management, those three things, really very little is going to stop what happened. So what happened was a huge decline in the population. It was more than a 95% decline over less than 10 years, which is the fastest recorded decline for a mammal species, and led to it being listed on the World Conservation Union's red list of threatened species as critically endangered. And it jumped straight from not threatened to critically endangered in one jump. So this is my 28 years. So I started Saiga work in 1990. We have the economic collapse coming in a little bit later. Then we have the conservation, international conservation kind of revving up, and it was listed on the Convention on International Trade in Endangered Species as something that shouldn't be internationally traded. It was listed as critically endangered on the red list, as I said, and then it was put on Appendix 1 on the Convention on Migratory Species. So these are all listings that say internationally this species is in trouble. You can see after a while, things started to improve as people got organised, the governments got organised, the conservationists got organised. So a memorandum of understanding with an action plan was started, and the Saiga Conservation Alliance, which I'll come back to later, was formed as a charity to try to support Saiga conservation. And then I'll come back to this later as the kind of last bit of my speech. Okay, so that's the kind of timeline of the good times and bad, and you can see why I'm talking about good times and bad now. So in my talk, I'm going to just give you examples of the research that I was doing at this time as a scientist. And I've got 5 little bits of research showing good times and bad. So let's start with point A, just after the end of the Soviet Union, when I've been doing Saiga work for about 3 years. So my first paper that I wrote about Saigas was a population model. It was about a population model of sustainable hunting. And what I was trying to look at was the fact that only males have horns, and if you hunt selectively for males, then what's the kind of level of hunting that you can do? Very like the kinds of things you do in wildlife management here. So that was my first paper that was happening in the good times. We were talking about how do you set quotas, basically. Let's go to B. The wobbly times, I'll call it. Maybe this is the times when things were changing, but we weren't quite aware of what was actually going on. So we were still doing basic science when things were actually starting to go wrong. So this is a PhD study that was done by my student, Eric Morgan, and it was about the transmission of parasites between sheep and antelopes. So the fact that there's a migratory system where both sheep and Saiga antelopes are moving large distances on the steppe. How do they interact through their parasites? This is a gut parasite called Marshalagia, which is, you have the eggs on the eggs are ingested in droppings onto the pasture, then they develop into larvae. The larvae kind of climb up the grass stems, they're eaten by the Saiga or the sheep, they go into the gut, they develop, and then they come out again. So here's the seasonal migration, which was followed both by Saigas and by sheep in the old days. Down the south is the desert zone, and the blue is the winter range in the desert zone, and then in the north is the steppes, so the grassland areas, which is the summer range. And the reason why both sheep and Saigas move between those areas is that in the winter, the desert area is relatively snow-free, and it has little bushes, and so it's possible to find food. Whereas in the summer, the desert zone is very, very dry and there's nothing to eat. In the steppe area, in the summer zone, in the summer, the grass is up to here and there's plenty to eat. And in the winter, the snow is up to here and there's nothing to eat. So they're moving to follow the greenery and to get away from these very high levels of snow in the summer. So what was interesting about this work was to think about how this movement of tigers and sheep affected their parasites and the transmission of their parasites. So this is what I said before about the fact that the parasite is inside the host. The host is the box at the top, and P means parasite. And then the eggs go out onto the pasture, and then they develop into larvae and go back into the host. And what was different about this was that we looked at the 3 different areas where they might interact in the north, the centre, and the south of the range. Okay, so the results are, if you just look at the second bar, so this is the percentage of the transmission of the parasite that goes from tigers into either tigers or sheep. Transhumant means sheep that move. So you can see that generally tigers are not a very big source of parasites for other tigers, for the moving sheep, but they are a big source of parasites for sheep in the north and somewhat for sheep in the south. And this was interesting because it meant that as the tigers come to the north where the sheep are, then you should be worming against these parasites once the tigers have appeared, so that then you can get rid of the eggs, and then that'll also stop the tigers taking the eggs down south. So that was the bit of work we did then. So that was B. But by C, frankly, we couldn't ignore what was going on, the fact that the population was virtually non-existent and heading fast towards extinction. And so this was the time when we started to think about humans and about how, why people were poaching and what could be done about it. So this is my student, Eleanor, and she started to do some interview work to try to understand the motivations for poaching. So what she found, first of all, was that people felt very positive about tigers. And this kind of result has been repeated on every survey we've done in every country since then. And so people cared about tigers. They didn't want them to go extinct. They wanted to help. And interestingly, she was able, through kind of indirect methods, to know which households were poaching or non-poaching households. And there was no difference between those households. So the question then was, why are people poaching if they care about tigers? So the main graph is another piece of work in which she asked about all the different professions that were available to people in the village. You can see there are professions like driver, livestock farmer, enterprise, industry, and poacher. And these were then ranked by the participants across 6 axes, including prestige, physical risk, would you like your son to do it, money, those kinds of things. And then the ranks were summed to get an overall kind of preference for these jobs. You can see that livestock farmer is the most wanted profession, and I've put a little circle around poaching, and poaching is basically one better than being female. So the bottom one is being female, housekeeping, and the next one is poaching. So that's how bad it was. Okay, so then we can do a little regression model to see whether or not a family is a poacher or not. And we found out about whether they were a poacher through kind of triangulated means. So if they said they were a poacher directly, or if 3 independent people in conversation while she was engaged in her fieldwork said that someone was a poacher. So what we can see here is that poor people are more likely to poach, and also unemployed people, fair enough, and also people who own motorbikes. And that's because people who own motorbikes are shepherds. They use them to go out onto the steppe, so they're out on the steppe anyway. And the second thing is that you use a motorbike to poach a tiger. So on these great long steppes where they have huge migrations, tigers have this mode of movement, which is like this. They can't really bend. They can't turn corners fast because that's not efficient for migration. That means that if you chase them on a motorbike, in the end, they'll drop dead. So that was why. So we had some understanding of why people poached. Okay, so after that, a lot of my research on tigers also diverged into conservation. So I was interested in how to engage in conservation to try to help people in the range states to change their behavior. We do educational work, we do work with schools, we do all sorts of stuff. And so we founded a charity called the Tiger Conservation Alliance in 2006, which is still going strong. If you're interested, the website is there. But I'm going to move back now to our research. And I'm going to talk about D, the better times. And here's a picture of Navinder Singh here, who worked on this. So this is when we were starting to think about, okay, so conservation is starting to work. The government is starting to put in place protected areas, and maybe we have a future for saigars. And if we have a future for saigars, we should start to think about what is going to impact that future and how can we mitigate any impacts to make the future better. And so this is some work around climate change and looking at the birth sites. So the saigars stop in the spring to give birth. And you can see here a 40-year time series from the monitoring of the Institute of Zoology, taking where you can see clear shifts. So the pink at the bottom is the 1970s. This is where they gave birth in the 70s. And the blue is the 2000s. So you can see a clear shift in birth areas over time, which is probably linked to increasing temperatures. So we have some kind of idea of climate change. And Navinda also showed that during that period, they were also avoiding humans more. So the first two, distance to town and distance to water, is about human avoidance, and the rest are environmental weather factors. You can see a clear avoidance in the periods where the poaching has been going on, basically. And also that habitat is getting less and less suitable for them over time. So the low quality habitat is increasing. So then Navi thought more about, okay, so now we know about this. We know about climate change and what drives saiga distributions. How can we help them to put the protected areas in the right place that are robust for the climate in the future? So not just now. So this is the data on suitability of the habitat in the 1980s in that top left-hand corner. That's what was traditionally where the saigars were, and the black is very suitable and the grey is a bit suitable. And then the current distribution at the time of the work was much more patchy and slightly further north and much less suitable habitat, mostly because of human disturbance. And then thinking forward about what happens if we succeed in conservation? What happens if the saiga numbers are restored to how they used to be, but we also have climate change? Where will the saigars be then? And so that first one there is shifting it up. And then what if we don't manage to get the saigars back to the numbers they are now? What if they stay fragmented in small herds? And there's also climate change. Where will they be? And then what's interesting here is that you might not be able to see, but there's little dotted things here which show where the protected areas currently are. And the point we were making was you are putting your protected areas, you can see best on that current distribution, you're putting the protected areas where the saigars are now. And that is very short-sighted. You shouldn't be putting them where they are now. You should be putting them where they are now and maybe in the future. So we were trying to help people to think in a more climate-robust way. Okay, so that was all very nice. Things were going well. We were doing research that was forward-looking and exciting. And this is a picture that was taken in 2015 by Albert Salimgarev, who is a researcher with an NGO in Kazakhstan. And the old-timers who were doing aerial surveys in the 1990s before things went bad were saying, this is great, you know, we're starting to see the saiga in large numbers back to how it used to be. We're starting to feel like things are going well for us. Never say that. Because the next month, what happened was a die-off of the type that is unprecedented, not been seen before, really. So in that population, the Betpak Dala population, which was the largest population, we lost 88% of our animals in 2 weeks. And that was 62% of the whole population of the species in the world. Extraordinary. So to answer that question, why did that happen, and try to think about solutions, we assembled a big multidisciplinary team, collaborative team. You see Navinda again, not aged at all, you can see there. And then you can see Eric Morgan, who was my student who did the parasitology work early on, so bringing together all these things that have happened before. And then someone from the FAO, a rangeland scientist, some vets, microbiologists. We had to have a very big team in order to answer this mystery of what had happened to these animals. So here's a little detective story for you. The first thing when you're thinking about what might have happened is that you have to think about it over a very large area. So these animals died in the red dots. So never mind the other colours, they're just protected areas and things. But you can see here, this is 100 kilometres, and these are the areas where dead saigas were found, these red dots. The area is 168,000 kilometres squared. That's the size of Greece. So you have to have some factor that was acting over a landscape scale, which is quite hard to think about. What happened was that they were calving, so they were widely spaced in the pasture, ready to put their calves down. So they stand in these big herds, tens of thousands of animals, and they all space out and they have a baby at their foot. It seemed like they were dying at pasture where they stood. It all happened very, very quickly. So, as you know, when you have an infectious disease, so the first thing you might think is this was an infectious disease. But when someone has flu in an auditorium like this, the person sitting next to them is the most vulnerable. And then after that, the person sitting next to them and the person sitting next to them. So infectious disease travels in waves between people, and it takes a while. Something that happened so very quickly could not have been an infectious disease, apparently not through contact. The other thing that was really odd was that we didn't see any survivors. So within these big herds, everyone died. That's evolutionarily not sensible. Not sensible for the parasite apart from anything else, because it needs to be carried on. So that was a bit weird. Here's a picture of a killing zone. Yeah, there's thousands of animals and you can see they've dropped dead and they're kind of systematically spaced. It was horrific. So I shall spare you any more pictures of dead animals and go to the histology. And the diagnosis was pretty clear, both from the field teams who were there looking for it, but also from a range of different methods, which was that it's something called Pasteurella multocida type B, which is a bacterium that causes hemorrhagic septicemia. So hemorrhagic means bleeding, septicemia means, blood poison. So bleeding of the blood into the internal organs, basically. What's interesting is that Pasteurella is an opportunistic parasite. It's a latent bacterium. It sits in the respiratory tract of the animal, apparently doing no harm, and then it seems to have been triggered somehow to become virulent and to kill them very, very quickly. So what would cause a latent bacterium to suddenly become virulent? So the next thing we did was a bit of detailed detective work and tried to find any mention of Sayga deaths, large mass deaths in the literature. And we found some, but most of them were not relevant. So they die very often in harsh winters in very large numbers. In the old days, before vaccination, they used to get foot and mouth disease from livestock, and that killed them. But then there were some other things that might or might not be Pasteurella. The problem is that because Pasteurella is in the nose anyway, when you find a dead Sayga and you post-mortem it, you will find Pasteurella. That doesn't mean that Pasteurella killed it. So there were only a couple where we felt that the mortality was very high, the numbers were very high, and it was similar in appearance. And those were 84 perhaps, but also particularly 1988 and 2015. There seems to be nothing before the 80s. We don't know why. We looked into folklore, we looked into poetry. You know, you would expect if thousands of animals died on the steppes, someone would notice. So the 80s is the earliest. And I'll just show you a picture from 1988, which I found in the archives. Extraordinarily similar. And, you know, guys who were there at the time noted that everything was very, very similar. Okay, so we took those records of disease that we felt were pretty confident that was the same thing. So there were 3, 81, 88, and 2015. And we looked at all the different environmental factors that might be similar or different between those. And the black is the control. So these are places where Saygas gave birth and didn't die. And the different colours of where they did die. And you can see very, very clearly a cutoff in terms of humidity. So in the 10 days before the deaths, it was much more humid than normal. So that's the first one. And then less clear cut, but particularly in 2015, it was warmer than normal in the 10 days before they started to die. So it seems like it's an environmentally triggered, weather-related thing. And that actually compares with other research that's been done on Pasteurella. It's quite commonly found in domestic animals as well, actually, and in other wildlife. And it tends to be about environmental conditions, but never happens at this kind of scale. So the next thing to think about is there something in the life history of the species that might predispose it to have this mass mortality from Pasteurella when others don't? So the Sayga is a powerhouse species. It's a species that can recover incredibly quickly when left alone. So you can see here, this is the population increase over time up to the point at which it died, 42% a year. That's unprecedented for an ungulate species, so it can bounce back very quickly. And it has the highest calf weight known to ungulates. So for a female with male twins, it can be up to 30% of your body mass can be fetus. Anyone who's been pregnant would be horrified about that. So it's a species that has a lot of, that's very fecund, very large calves, and it's very precisely timed in its calving. So you have these huge aggregations, and what they're trying to do is hit the peak of greenery. So there's a very short period in which the grass is really good, and they want to time it to hit that peak. But if they're too soon, then it's still cold and the calves die. If it's too late, then the grass dies. And so it's a particularly stressful period. Okay, but that's fine, but it's stressful every year. You know, what's the difference between one year and another that means one year thousands of animals die? But maybe it's particularly sensitive to phenological change. So to summarize, we know what they died of. We know they're vulnerable. Maybe there's climate change, but there's so many questions. It's so frustrating to do a detective story with no end. But now we're looking at research. And while we do that, we have to remember that ongoing threats remain. So that there is 5,300 horns that were seized on the Chinese border in October of the year that the die-off happened. So very large numbers of horns. There's also still illegal poaching for meat. In 2012, a barbed wire fence was put here in the migratory route of the Ushchut population, another population. That's a track from a radio-collared female. You can see it's cutting through there. So they can't get down to the winter anymore. This is a new railway, an oil and gas pipeline that's cutting right through the birth areas. So even though we might solve the disease problem, the other threats remain. So to summarize, 28 years of SIGA research. So I've moved from theoretical models to research of direct practical use to managers, and I think that's the way that we're going in conservation in general. It's much more interdisciplinary, it's much more collaborative than it used to be. The studies build on previous knowledge. The disease thing came as a shot from the blue. We didn't realize it was going to happen, even though we'd been working on disease 10 or 15 years earlier. So we didn't realize that disease was a problem, but we had still got that previous knowledge. I have to say that these are just a few lines of research, and many of the lines of research I thought were most interesting didn't get funded. But that's the way with research. And so many more questions remain. Thank you very much.